Alright, so we've got, this is slightly harder. It's going to use the implicit differentiation technique we did previously. We're going to find an equation with a tangent to the curve y equals 2 to the power of x at the point 1, 2. So, same as finding the equation of a tangent previously, y minus y1 is mx minus x1. And m is the gradient, which you get by finding dy dx. So the difficult thing here is differentiating this thing, y is equal to 2 to the power of x. This you can't differentiate like in C1. You can't take 1 off the power and times by the new power. That doesn't work because the power is an unknown. It's x. All right? So the way you try and find dy dx is like this. You say y is equal to 2 to the power of x. I haven't changed anything there. I can't differentiate that as it stands. So the trick here is you have to take natural logs of both sides. So taking natural logs of both sides gives us natural log of y is log of 2 to the power of x. You might think, well, why on earth have we done that? Well, the reason why we've done that is because I can now rewrite this side so that power isn't up there anymore. What can I do with that power?
Oh, times at the front.
Times it at the front. So I end up with that thing there. Happy with that? Now I can differentiate that implicitly. So, what is the differential of log y? 1 over y. Close. Good start.
Dx. So it would be dx over dy.
Not quite. You've got the right idea though. It's 1 over y times by.
Dx dy.
Not dx dy.
Dy dx.
Dy dx. Perfect. And that's equal to, what's the differential of x log 2? Now think about this as what's the differential of 3x? The differential of 3x is? It's not a difficult question. C1, 3. What's the differential of 8x? 8. Now this log 2 is just a number, so what's the differential of log 2 times by x?
Nothing. 1 over x.
No.
Nothing.
That log, don't get confused with that log thing. So as I said, the differential of 3x
2 over x.
is equal to 3. The differential of 8x was 8. So all this x log 2 thing is, it's log 2 times by x.
So it's log 2.
It's just log 2, isn't it? A bit like that number, that's just a number 3, that's just a number 8, that's just a number log 2. So the differential of log 2x is just
So you
log
only,
2.
you only do the 1 over when the unknown is like with the log.
Exactly right.
Okay.
Exactly right. And then if I rearrange that slightly, I get dy dx is equal to y log 2. If I wanted to, and sometimes I might ask you to do this, y is 2 to the power of x, so I could put it all back in terms of x if I wanted to. I don't really need to be fair. I know that x is 1 and y is 2. I could swap it in at any point, or any one of those things, to get what the gradient is. It makes no difference. Well, I've done this. I can use the value of x is equal to 1. I get dy dx is equal to 2 to the power of 1 times by log 2. In other words, just 2 log 2.
Why did you put the x to the front in the first place?
Why did I? Because this is a power, and it's log. And if you remember back to C2,
I know how you can do it, but I don't see why you do it.
because when it comes to the front, I can now differentiate it.
Why can't you do
I couldn't differentiate it when it was a power. How would I differentiate it if it was a power?
No, you just times.
You're thinking of, if you have x cubed and you differentiate that, you get 3x squared, which is true.
I'm thinking of that.
But the thing is the power, so you can't actually do
So
that.
when you have x ln 2,
Uh-huh.
to differentiate it, you just.
So this is just a number.
Yeah.
I don't know what it is, 0.6-ish, I think.
So it's like 6x.
Yeah, so differential 6x is 6.
And if it was just ln 2 differentiated again, it'd just be 0.
Exactly right.
And if it
Exactly right.
was x squared, could you get x squared?
Yeah, well, it's unlikely, but if it was x squared log 2, it would be 2x, because that's what the difference of x squared, and then times by the log 2.
And if it was 2x ln 2?
It would just be differential 2x is 2, so 2 log 2. Rosie.
How come you just leave? You can just like add the log in, and then just like leave it.
Why did I take logs in the first place?
Yeah, like how
Because-
it can just carry on.
Yeah. By taking the logs, I haven't changed the equation because I've done the same to both sides. It's still true.
Oh, there we go. That's fine. Okay.
Okay,
Alright, you've made it a log so that x is in a power.
precisely right.
And when you have the 1 over y dx, how does it move to the y side?
Well, what I've done here is I've times both sides by y.
Dividing it instead of timesing it
Exactly.
one over.
Yep, exactly right.
And then to get the 2x, where does the x
Well,
come
I'm
from?
right at the very start. Y is 2 to the power of x.
Yeah.
So I've just swapped y.
Oh, so you
The
put
2 to the
2x
power of
in
x.
there. And then you can work out x somehow.
Well, I'll tell you x in the question.
Oh!
So x is 1.
Then use it, okay.
And once you've got that, the equation of the tangent.
So the gradient is just y ln 2.
The gradient is that in there, 2ln2.
Why is it 2 ln 2?
Because,
Not the gradient, I mean for the general curve,
yeah,
the dy over the differential of the general curve
Yeah.
is
Is-
y ln 2 or that.
exactly right.
But it can be either.
It could be either, because we're told what y is anyway, so it makes no difference.
So with that, if you want at any point, you only need. So if they give you like a as 1, so like guess what a is, and they give you y. Instead of most of the time where you have to, you only can use x.
Yeah.
Here you could use y.
You could, yeah.
Gradient.
Yeah.
I need to write that down.
No problem at all. So we end up, so equation of the tangent, y minus y1, m x minus x1, y minus y1 is equal to m, which is 2 log 2, x minus 1. And you could simplify it if you want to, but the question says find an equation. That is an equation. And unless it says specifically what it wants it to look like, you're allowed to leave it like that. So I will.